Hello everyone, I am your Digital Machinist. In today's video, I'm going to show you how to program a CNC machine entirely on your own. We'll go through the complete process, starting with writing the G-Code, all the way to a detailed simulation in CIMCO software. If you want your machine to run perfectly and without errors, you're in the right place. The software is CIMCO Edit 2025, and today we process the sides of a workpiece that is 80 millimeters long, 80 millimeters wide, and 10 millimeters thick. We use a tool with a diameter of 20 millimeters. Let's get to work. To start writing G-Code, we need a new file, which you can find in the top left corner. First, we need the basic positioning and safety commands. One of these is the G54 command, which is used for selecting the work coordinate system. This is followed by the commands G21, G90, and G17. G21 sets the input units to millimeters. G90 allows absolute programming, which means that each coordinate is measured from the initial 0 point. G17 is used to select the XY plane. Moving on, we'll set up the first tool by entering the command T01 followed by .em06, which instructs the machine to perform a tool change, or in this case, .load the tool. We also enter .S2000 for the spindle speed and .M03 to set the spindle rotation to clockwise. G43 is one of the most critical commands in CNC programming, as it activates tool length compensation in a positive direction. In addition, we use M08 to activate the flood coolant or emulsion. Now, let's move on to the core. The G0 command is used exclusively for moving the tool through the air. The tool travels at the maximum speed allowed by the machine to reach the target point. Important: never use G0 while the tool is inside the material, as this would lead to a serious crash and tool breakage. The X, Y, and Z axes define the direction of the spindle's positioning in space. The X moves left and right, Y moves forward and backward, and Z moves up and down. Now, we will position the tool near the workpiece at Y-10 and X10, then we'll lower it to Z-5. Based on these coordinates, we know exactly where the tool is located. Our first cutting move will be G1 Y90. Since our workpiece is 80 millimeters long, we must move past it, which is why we use Y90. As you can see, the blue line represents the tool's path. We don't need to enter the X and Z values again. They will simply remain at their previously set coordinates. Alright, let's shift the tool right to X20 and back to Y0. This clears out the extra material on the left where our two holes are going. Next, we're heading over to X80. Then up to Y80 and finally hitting -X10. That should perfectly clean up all the edges, exactly like the blueprint says. We're adding G0X -30Y -20 to move the tool away from the workpiece. Your screen won't look like this just yet, because we haven't entered the stock dimensions and the tool diameter. We'll get to that in a bit. Moving on to drilling, we are adding a new tool, T02, and following the same steps as before. While using a rapid traverse G0, we raise the tool to Z20 and position it over the hole at X15Y10. Then, we enter G1 and lower the tool to Z-15, since the workpiece is 10 millimeters thick, and raise it back to Z15. Because the second hole shares the same X-axis as the first, we'll leave X as it is and only move YY to 70. We then repeat the process of lowering and raising the tool before using rapid traverse to move it back to the safety zone. And now that our code is finished, go to the top and select Backplot, then Backplot again. You can now see the 3D animation of our tool path. To add a simulation of the material, click on Add Stock. Once the stock is added, you'll notice the dimensions aren't set yet. Go to Properties on the right and enter the height, width, and length. Under Origin, we'll select Top XY, then click on Work Origin and enter 0 under Translation. Now, we have successfully positioned our workpiece. Now, let's set the tool diameters. Go to Tool Setup at the top. You'll see the two tools we entered in our code. Click on the first one, then select End Mill Flat. In the window that pops up, go to the diameter field, enter 20 and save your changes. Repeat the same steps for the second tool, but switch the type to Drill and enter 8. Now that we've set everything up, you can see the workpiece matches our assignment perfectly. Drag the slider to the start of the simulation and hit play to see our final result. As you can see, the code and simulation are working perfectly without any errors, and our final workpiece matches the assignment exactly. That's it for this short tutorial on the basics of CNC programming. If you'd like to see more content like this, make sure to leave a like and subscribe to the channel. If anything was unclear, feel free to leave a comment below. This is Digital Machinist. Thanks for watching, and I'll see you in the next one.